Bismillahirrahmanirrahim. So let us discuss transfer function, impulse response, and convolution. The transfer function of a network or circuit is the ratio of the output response to the input, right? So let me write it down. The transfer function of a network or circuit is defined as the ratio of the output. So output is a response. So output response to the input. So input is excitation. So input excitation assuming that the initial conditions are 0, right? So if output in the frequency domain is y of s, input in the frequency domain is x of s, right? Then the transfer function h of s is equal to y of s divided by x of s, right? Y of s divided by x of s. So note that the transfer function is defined in the frequency domain. The h of s is defined in the frequency domain, and the frequency is kept variable, right? So here s is frequency, so s is kept variable, and we can also derive the transfer function in terms of omega. So omega is frequency there. Omega or s is kept variable to derive the transfer function. So the transfer function has many uses. For example, it can be used to h of s is used to obtain frequency response of a circuit. The frequency is variable, and we can vary the frequency to find the output response. So h of s is also used to obtain output for any input, right? Because, for example, here y of s, we can write it like this: y of s is equal to h of s multiplied by x of s. So if we know the transfer function and if we know the input, we can find out the output in the frequency domain, right? We know the transfer function and we know the input, so we multiply them together to find the output in the frequency domain. So we can then find out the inverse Laplace transform of this output to find out the output in the time domain. One more observation is important here. We know that if the Laplace transform of f1t is equal to f1s and Laplace transform of f2t is equal to f2s, then f1s multiplied by f2s is equal to the Laplace transform of the convolution of f1t and f2t, right? So we see that we are multiplying two functions here, h of s and x of s. So they are multiplied in the frequency domain, so it means that they are convolved in the time domain. So in other words, we can write it like this: y of t, the output in the time domain, is equal to h of t, the inverse Laplace transform of the transfer function, convolved with x of t, the input, right? Where, let me write it down, where y of t is the Laplace transform, the inverse Laplace transform of y of s, and h of t is the inverse Laplace transform of h of s, and x of t is the inverse Laplace transform of x of s, right? So this is an important observation. So if we have the inverse Laplace transform of the transfer function in the time domain, then we can convolve it with the input in the time domain to find the output in the time domain, again in the time domain. However, this involves convolution, which may be a complicated process because it involves an integral, evaluation of integral. However, this process of integration in the time domain is reduced simply to multiplication process in the frequency domain. We just need to multiply the transfer function with the input to find the output in the frequency domain, and we can then apply inverse Laplace transform to find out the output in the time domain. There is one special observation. For example, when x of t is an impulse function is this del t, right? So then x of s, the Laplace transform of del t is 1, right? So x of s is 1. In that case, so x of s 1, so it means that y of s is equal to h of s, right? And that means y of t is equal to h of t. So when the input is an impulse, a unit impulse, then the output is equal to the inverse Laplace transform of the transfer function. So we can say that the inverse Laplace transform of h of s, so h of t, which is the inverse Laplace transform of h of s, is unit impulse response, unit impulse response of the network, right? That is, it is the time domain response of the network to a unit impulse, right? So an h of s is simply the Laplace transform of the unit impulse response. So this is an important observation. So if h of t is known, if h of t is known, that is the transfer function, right? Inverse Laplace transform of the transfer function or the unit impulse response is known, the response to any input is obtained in the S domain, by multiplication, by simple multiplication like this here. in the S domain by multiplication. Or in the time domain using convolution like this here, using time domain using convolution, right? But obviously, as I said earlier, the multiplication process in the frequency domain might be quite simpler than the convolution process in the time domain. So that is why we use the frequency domain to solve circuits, right? So in the frequency domain, we simply need to perform multiplication of the transfer function with the input in the frequency domain to find the response.